Section 5.2, we're going to talk more about systems of equations. Back when you were a little old algebra student, what were the different ways you learned to solve systems of equations? Substitution. Elimination. And earlier this year, we learned a technique called Cramer's rule. Using matrices is really exactly the same as doing elimination. All you're doing with a matrix when you solve using a matrix method is you're not writing down the x and the y each time. You're just dealing with the coefficients. And the truth is, that's all that really matters. So the matrix solutions that the matrix techniques that you might have learned is really just a special application of elimination. All right, so I'm just going to grab a problem out of the book here. This is number 4 out of section 5.2. It has x prime equals 3x minus y. And then it has y prime equals 5x minus 3y. And some initial conditions. X at 0 is 3. Y at 0 was 2. All right, so let's solve that first by substitution, which is what we kind of did the other day in section 5.1. How would you solve this one by substitution?
You take the derivative of the first one and then substitute the y prime in for fx as y.
All right, so basically what you're going to do, the way I would think of it is, I'm going to take this equation, I'm going to get y all by itself. Then I'm going to take the derivative, and I'll take that derivative, I'll plug in for this y prime, and whatever I get for y, I'll plug it in over there. And I'll end up with an equation that only has x's in it. All right, so this would be x prime minus 3x equals negative y. So y is negative x prime plus 3x. Which means y prime is negative x double prime plus 3x prime. And you're exactly right. Now you're going to take those two things, you're going to take the y and plug it in there, and the y prime, plug it in there, and you'll only have x's left. That gives us negative x double prime plus 3x prime equals 5x minus 3 times negative x prime plus 3x. All right, a little algebra here, a little cleaning this up. Minus x double prime plus 3x prime equals 5x plus 3x prime minus 9x. And then I'm going to move this negative x double prime into 3x prime. I'm going to move those over to the other side. I get 0 equals x double prime minus 4x. The 3x primes, those reduced each other out. Now what? R squared minus 4. Factors as r minus 2s plus 2. Which means what x is C1 e to the 2t plus C2 e to the negative 2t. And then what about y? It's not the derivative. Unfortunately, to find y, I have to take minus the derivative and then add 3 times the original thing. A little bit long. So y is minus the derivative. So the derivative is 2c1 e to the 2t minus 2c2 e to the minus 2t. And I have to take that whole thing and multiply it by negative 1. Plus 3 times the function. So that's going to be plus 3c1 e to the 2t plus 3c2 e to the negative 2t. Distribute the negative sign through, combine my like terms. I have negative 2c1 plus 3c1. So that's c1 e to the 2t. And then I have a minus 2c2 and a plus 3,2. That's a 5c2 e to the negative 2t. So it wasn't too bad. Take the derivative, multiply by 3, add them together. Last step.
Plug in your givens.
Plug in my initial conditions, figure out the values of c1 and c2. When I plug in x at 0 equals 3, I have 3 equals c1 plus c2. I plug in this initial condition, I have 2 equals c1 plus 5c2. How would you solve that system of equations?
With a matrix.
With a matrix? You guys love your matrices. I would just go ahead and I would subtract those two equations. 3 minus 2 is 1. The c1s go away. Equals minus 4c2. So c2 is negative a quarter. Which means c1, when I plug negative a quarter in and then add it over there, I get 13 quarters. Alright, so my final answer is x equals 13 fourths e to the 2t minus 1/4 e to the negative 2t, and y equals 13 fourths e to the 2t minus 5/4 e to the negative 2t. Questions on that?
Where did 5 words come from? Oh, never mind.
Why this had a 5 in front of the c2.
Oh, I see.
I had to multiply that negative 1/4 by 5.
For the y, there's a e to the negative 2t, that first one.
Sorry. That should be a plus, yep. Other questions?
Pretty straightforward.
Pretty straightforward, all right. Let's do the same problem again, except we'll do it using elimination. X prime equals 3x minus y, and y prime equals 5x minus, no, what was it again? 5x minus 2y? And then we had x at 0 was 3, and y at 0 was 2. All right, so how did elimination work back when you were a
It was subtract.
little old algebra student?
Subtract is same things. Like you have like positive 2 and negative 2, you just subtract them.
Yeah, it's exactly what I did right here, isn't it? Sometimes you have to multiply one equation by a number and then add it to the other to make things go away. But it's exactly what I did right there. I used the elimination method. Okay, so here's what we're going to do for systems of differential equations. I'm going to rewrite these. I'm going to write this as x prime minus 3x plus y equals 0. And then the second one I'm going to write as minus 5x plus y prime minus 3y equals 0. So what did I do?
Made everything homogeneous.
I did make everything homogeneous
By moving all the variables to one side.
by moving all the variables to the one side. If this original problem had, say, a plus sign t here,
You left down the right side.
then I would have left that on the right-hand side. So basically what you're doing is you're getting all the x's and y's on one side, everything else on the other side. But in this case, everything else was just 0.
Or is it easy to plus 3y?
Sure it does. Plus 3y. Thank you. I'm in trouble with my pluses and minuses today. All right, and then I'm going to rewrite this again. I'm going to write this as d minus 3x plus y equals 0. The heck is that? What does d stand for?
Derivative?
D stands for derivative.
Okay.
Right? So if I were to take this x and distribute it through where d means derivative, I would get derivative of x, which would be x prime,
Oh,
minus 3x.
Okay. Why did you do it?
Why did I do it? Well, you will see in a minute here.
I think it's cheating method.
So what would the second one be? The second one would be negative 5x plus d plus 3y equals 0. Well, I'm not going to try to cancel out the d's. What I'm going to try to do is either cancel out the x's or cancel out the y's. So I want to multiply one equation by something and add it to the other one and make stuff go away. If I were to take this top one and multiply it by d plus 3, I would have a d plus 3y here and a d plus 3y there. I could then subtract my equations and I could get rid of the y's. And that's exactly how the elimination method works when you're dealing with systems of equations. Okay, so I'm going to take the top equation and I'm going to multiply it by d plus 3. That gives me d minus 3 times d plus 3x plus d plus 3y equals 0. And the second equation I'm not doing anything to. That's minus 5x plus d plus 3y equals 0. Now what?
Subtract.
Subtract the two equations and the y goes away.
Wait, doesn't one of them need to be positive, one needs to be negative?
That's how we're subtracting.
That's why we're subtracting them. Normally we make one positive and one negative. Your other option is to leave them the way they are and then just subtract the two equations.
Oh,
And then the y's go away anyway. All right, so we have d minus 3 times d plus 3x plus 5x equals 0. Well, it made the y's go away, but now what do we do?
Could you redistribute the x?
What do I get if I distribute d minus 3 times d plus 3? I get d squared. What does d squared stand for? Second derivative. That's a kind of a cool thing. These are called, this d thing is called a differential operator. And it's kind of cool that you can write the d thing down and you can treat these just like regular old polynomials, regular old binomials, and things work out. You take d times d, you get d squared. That stands for second derivative. And then when you do FOIL, the middle two terms cancel out. You get a 3 times the derivative, a minus 3 times the derivative. Those go away, and then you get a minus 9. So this becomes d squared minus 9x plus 5x equals 0. D squared stands for second derivative, so that's x double prime. Minus 9x plus 5x is minus 4x equals 0. And what did we end up with? Exactly the same equation as we did it with substitution.
this is why we never use d as a variable.
And that's why you never use d as a variable. You can use little d as a variable, but not big d.
We used big D when we did partial fraction.
Yeah, we did. That's true. All right. It didn't mean derivative then, though.
Once you distribute that x to d squared, you use x
That's right. D squared means second derivative. So when I distribute the x through, that means take x and do the second derivative. So there's my second derivative. Questions on that? All right, so I'm going to stop there because you're convinced you're going to get the same answer, right?
Yeah.
Well, let me ask you one question, though. What would you do once you get the x? X equals c1 e to the 2t plus c2 e to the negative 2t. How are you going to find y? Yeah, I think you still have to go back up top and plug in, and that's what you do with elimination anyway, right? When I found that c2 was negative a quarter, I had to take that negative a quarter, plug it in, and find the c1. Same exact thing works here. Once you find your x, I'm going to have to take it, and it's kind of a pain in the neck. I'm going to have to take it and probably plug it in there, and I'm also going to have to find derivative and plug that in. I hope if you can see what I'm pointing to. And then solve for y. Once you get used to using the D operator, it's about the same amount of work. Either way, it's going to work pretty well. All right. How about if I were to take this same thing that I had right here, I'm just going to write it down again, d minus 3x plus y equals 0, and minus 5x plus d plus 3y equals 0. And I told you to do Cramer's rule. All right, so how did Cramer's rule work? We use a matrix. In fact, we use 3 matrices, don't we?
Yeah.
So we create a matrix. Usually you call one matrix D and one matrix D sub x and one matrix D sub y, but I don't want to use D. Why not? Because I'm using D for derivative. So I'm going to use M for matrix. So matrix M is traditionally the coefficient matrix, which in this case is D minus 3, 1, negative 5, D plus 3. How do you find M sub x?
Put zeros in the first column.
Put zeros in the x spots. So you put 0 and 0 here, and then you're going to have 1 and D plus 3. And then what was our traditional technique for finding x once we had M sub x and we had M?
You gotta find the determinants.
You have to find the determinants, and then what do you do?
Find the determinant of M sub x.
You divide. So typically, when you do Cramer's rule, you write it this way. X equals, it's M sub x divided by M, and you take the determinant of those. When you do it with differential equations, you typically write it this way. The determinant of M times x equals determinant of M sub x. So what did I do? I just multiplied both sides by M.
Can you just put out really quick where the numbers were from?
Okay, so the M matrix is the coefficients. 1, 2, 3, 4. M sub x, you take whatever these answers are, and you put those in the x spot, and then you leave the y values exactly the same.
What about M sub y?
If I wanted to find M sub y, I take these answers and I put them in the y spot, so I would have zeros over there. And then the rest of M sub y is exactly what you had for M. So you would have a D minus 3 and a minus 5. Max.
I'm going to need to have a third one.
What's that?
Why don't you have to solve for M sub y?
Well, because what I'm going to do, I'm just going to find x, and then I'm going to take x and I'm going to substitute it in. You could find x and y separately, and then what you would have to do is go back to one of your equations and plug them both in
Yeah.
and get relationships between your variables.
Okay.
That would work also. I think it's easier to find one and just take one and plug it in. All right, so notice how this works here. What's the determinant of the M matrix? You have D minus 3 times D plus 3 minus, and then you multiply the other diagonal, 5. All that gets multiplied by X equals, what's the determinant of the MX matrix? 0, because you multiply that way, you get 0. You multiply that way, you get 0.
I think you dropped the.
Yeah, it should be positive.
Moral of the story is, look what we get. D squared minus 4 times X equals 0, which is X double prime minus 4X equals 0. We get exactly the same equation yet again. Questions on that? So, if I give you that problem on a quiz or a test, which way should you do it?
Either
Combination or whichever way. Anyway, really.
My answer is whichever way you like best. Am I going to care which way you do it?
Nope, you got graded either.
You're gonna get it right. I got to grade it either way.
Does that mean you have to do it either way when you?
My directions will be solve. That's all it will say.
I'm saying, so you're gonna have to check it. You're gonna have to do it both ways.
We'll do it all 3, 5, or something.
So you just made twice as much work.
I'm aware. So you better get it right, or you're going to make me very angry. Because I'm going to write my answer key one way, and then if you do it a different way and you don't have the right answer, and I got to rewrite another answer key, oh, you're in trouble.